the subgraph.yaml file defines what spec version we're using. So this is version 1. You have your description of your subgraph. Optionally, you can put in a repository where you will store that on GitHub. And then you're referencing all the important documents that define your subgraph, which are your GraphQL schema, your mappings, which define how you're going to transform your data, the contract address for the contract that you're indexing data off of, and then your events that you're interested in triggering off of, and then the functions that will be run when those events happen.
This is all configurable.
This is all configurable.
So you can just go here and just change the contract address.
Yep. Okay. You can change it to whatever you want.
Mainnet, testnet,
and then you can also do, we don't have it here, but you can do call handlers. This keyword.
I guess I'm a little confused here. Why does this even say mainnet? Like if I migrate using Truffle while it's connected to say Goerli, like what is this?
So that could be an arbitrary name. When you run your graph node, you can set up multiple Ethereum networks for one graph node, and you name those. So when you run your graph node, you do graph node start or run, and then you put in all of your Ethereum RPC values. So you might have an mainnet, whatever that URL is.
I see.
Goerli, Rinkeby, mainnet 2, mainnet 3, whatever you want.
Right.
And then based on what this is, it'll match that and then use that chain. Does that make sense? Yeah. So you define the events that you're looking. So I was just saying you can also do call handlers or event handlers or block handlers. I'm just not going to type anymore. A call handler will search through the blocks to find any time one of the functions on your contract was called, and it'll trigger off of that.
Do you mind if I record?
Sure.
Okay, so call handler and event handler?
Yep. Event handlers trigger off of events on your contract.
Yeah.
Call handlers trigger off when call functions were called. And then block handlers can trigger on every single block. If you just want to bring in like block data or transaction data off the block. And then what you do is you define the functions for how you want to take that data, transform it, and then put it into your schema. So you do that in your mappings. So here we have like a skeleton mapping file where we're importing the schema. So right now we have gravitars. It's a pretty simple schema, just one type. But you might have other types. You might have users, you might have events, whatever you want. And then what we do is we generate classes from these schema, and then you can import those into your mapping file. And then that gives you
import this into your mapping file.
So right here, so I'm importing the gravitar entity type from generated schema.
Where do you go?
So now I'm in the mappings. So if you go to source
mappings.
So if you run npm, one of the npm scripts, which is codegen.
Why does this not have any semicolons, dude?
Your types, and then with that type we have a generator, so you can generate a new gravatar. Every time you generate a new type, you have to give it an ID. And then on that gravatar, you have the owner property, display name, image URL. And so here, since it's an event handler, on the input to that handler, you have the event params. You also have the transactions and the blocks. So you can take...
I think this seems awesome, and I totally want to learn this before too long.
Yeah,
For this particular hack, I don't think we need events. All we really need is an indexed place where the prospective parents can search. It doesn't need to be like, oh, there's a new egg.
Yeah.
Like, wow.
So that just is what we can trigger off of.
Yeah, totally. And I totally I want to learn everything about the graph because it's going to be fun to play with the graph and new Cypher.
So how are you guys going to store it on the contract? Just in an array?
That's the real question. Like, we're going to make tuples of we need like proper modeling and number agreement and
Well, events are nice because you can just have that event trigger and the output of that event be a tuple. And that'll store in the contract. And then we can pull that off. So it'll store in the contract storage in the event output. And then you can just pull out that tuple and take out the properties you need and save it.
So each event can be a new index thing that I'm going to index, or not necessarily?
Yeah, so each event can basically be, it basically triggers this function, and then you can get data out of those events and define what you want. So let's go into like this event here. So
can you give me an example where I would use an event to...
Yeah, so this example here is called Gravatar, which basically is, you know what an avatar is?
Yes.
So it's just like a profile photo kind of thing. So this is like a simple contract that allows you to create new avatars that associate with your name. So this event is a new Gravatar event.
Okay.
So if you create a new Gravatar
Yes.
using that contract,
Yes.
you'll interact with that contract,
Yeah.
you'll create a new Gravatar, and that event will be triggered a new Gravatar event. What we do is we search through the whole chain, and every time we see that event, we'll stop at that event, and then we'll get that data out of that event, and we'll put that as an input to your handle new Gravatar function here. And so let's look at that. So the event is new Gravatar.
Yes.
So we can do this. We have like nice type completion here with TypeScript.
Sure.
So we go event. So on that event we have the address, we have the block. Within the block we have the author, the difficulty, gas limit, etc.
Okay.
You can pull that information out and save that to your entities. We also have the event params, which are specific to your smart contract. So depending on how you design that event, you'll have different params,
Yep.
different outputs.
Yes.
So in this case, we have the display name,
The owner,
so
like, yeah.
the
Sure.
URL, which is
Yeah,
what the
yeah.
image is,
Yes.
right? The owner, yep. The ID that identifies it. So every time that event is hit on chain, this function will run. And here all we're doing is we're making a new Gravatar entity, because we know a new Gravatar was created. And on that Gravatar, we're adding the owner property, which is the event params.owner,
Yes.
the display name, which is event params.displayName, the Gravatar image,
Yes.
event params.image,
And
and then we
it.
save it to the store, right? And so then it goes through the chain, and it just does that for every single event. So the idea is you'll have a new Gravatar entity for yours and mine, whoever made them. In addition, we have an update Gravatar, which works the same way.
Let's say I want to change the picture. So I'm still the owner. I still call this avatar the same name. Let's say Mickey Mouse.
Yep, and you change something.
So I just change the image showing and then save. So I call that function by generating an event, or
Yeah, so you'll already be doing that on chain,
yes.
and you can run all that smart contract stuff separate from us, and then after the fact, we'll just go in and help you get that data out, right?
Okay.
So in this case, we're like loading, we know it's an existing Gravatar that's being updated,
Yes.
so we're going to use this load function that is generated by our system to load that data out of the
Yes.
store. And if it's null, we create a new one just for safety.
Yes.
And then here we're updating this. The way that our system works is if you create a new one that is equivalent to an old one, it'll just update and merge and not overwrite. So here we only have to save it as if it's a new one, but it's the same semantics, and basically we're just merging into the old one. So basically here, all we're doing here is adding new Gravatars and updating them. Yep.
Yeah.
And
So
then we have
besides
this really
mapping-
simple,
yes.
this really simple schema. But you could have a much more complex schema with a bunch of different entities. You
Sure.
can imagine, right?
Sure. So you start building by creating a schema.graphql, or you call it like you have to call those names schema and then .graphql.
Well, you could name it something different. You just have to make sure that it's referenced
Like
in your manifest.
medical data.graphql,
Yep,
right?
sure.
And then I start putting blood type, age, whatever.
Yeah. So an important step there is if you're starting from scratch,
Yes.
you create this schema,
Yes.
and then
Set the object, right?
you run yard code gen.
Okay.
And what this is doing is it's creating all of our assembly script classes. It's loading up the ABIs. It's seeing what the event structure is, the call function structures are, And this is what allows us to do that type completion that I was showing you.
Yes, yes.
Because what we do is we're generating a file like this, where we have our base classes that are on every contract, Ethereum calls, Ethereum events, and then we're creating new ones specific to your schema in your contract. So the new Gravatar event, which has these params. So that's how I was easily able to do.
So this is all like object-oriented programming, right?
A bit, yeah. Some of this
Abstractions would be
stuff.
like, but then you have the base classes.
Our base project is mostly functional, but then this stuff is like kind of object-oriented a bit, yeah. And so this is what allows me to do that event.params.owner.displayName, which behind the scenes is really going event.param2, and then it's converting it to the type that you want. So that type is defined in your schema.
Yes.
So by defining that schema and generating this code, it made it so instead of writing event2.params.convert to string or something like that, all I have to do is do params.owner.
I see.
So that's how we've tried to make it easy for you to write these. I think that kind of covers most of it there, right? And then in package.json we have our npm scripts. So I was using like yarn codegen, which runs graph codegen.
And then
And so these are like the essential functions that you use. So the first thing you do is you run codegen to generate the classes.
Yes.
And then you develop your mappings, and then you can deploy that either to our infrastructure and have the data indexed, and then we'll generate a GraphQL API that you can
How do
hit.
you deploy the mappings to your infrastructure? So
So
after
basically,
you did the cold gen, that you went just like cold gen.
basically
name of the
you
file?
do this stuff. So you do yarn deploy,
Yes.
or so you do yarn create. But really the first thing you want to do is go to the graph.com /explore. What's up with your internet?
I don't know anymore. But like the documentation, right? Yes.
So these are existing subgraphs. So if you want to make a new one, you'll sign in,
Yes.
create a subgraph here, which will basically be a blank page that doesn't have anything on it yet.
Yep.
And you'll create the name, and you'll already be signed in with your GitHub account, right? So then, since that name, that unique name is already on there,
Yes.
then you can, after the fact, then do yarn deploy, and make sure that you have, your GitHub name
Yes.
and your subgraph name that matches with what you just created on our website.
Okay.
And you're deploying it to our APIs. So see the api.thegraph.com/deploy. So that deploys the subgraph to our node. This is our IPFS node.
Okay.
All this data that I've been talking about, the subgraph manifest, the schema, the mappings, the ABIs, those get packaged up and sent to our IPFS node, and so that we always have access to those. The other nice thing is that creates an IPFS hash that uniquely identifies your subgraph.
Okay.
So you can see here we have this ID, it's an IPFS hash.
Yes.
You can actually use this and directly go to IPFS and cat that and get all of those files down. So once you've deployed, that always lives on our IPFS node, and then we pull that down and use it to index your data. And then we have like this progress bar that'll show how much it's indexed through the chain. This one's already done, it's like up to the most recent block.
Yes.
And then we provide this HTTP endpoint here.
Yep.
You can use that in your web application
So basically, like
to query the data, right?
when someone submits a
And then you use GraphQL queries on your schema.
render the
So in this web page, you can actually test out the GraphQL queries. You can look at the schema that someone else has made. You can write a query, so this is a query here,
Yes.
and you can test it out. So this would be the results. So this is the kind of thing that you would put in your web app, and these are the results you would get, and then you would use that to display the information here.
card and the card.